So we continue to talk about the logic operation. We have talked about shift left logic, shift right logic. Now we move into the 3 bit by bit logic, and, or, and not. So for the AND one, actually straightforward. Let's just try to assume, okay? I only tell you, I want you to do the AND bit by bit and logic. I also tell you, this logic can represent by using R format. I want you to pause here to think. Okay, whether you are able to figure out without looking at the slides, whether you can figure out how to represent assembly language to implement the following high-level operation is implement and bit by bit and between the source operand T0 and T1, and then use the result to update S0. I want you to pause here, try to figure out whether you just know, R AND is an R format, whether you can figure out how to represent this high-level operation by using the assembly language. You pause here and try to figure out, and then you continue again, okay? So I think I can, if I'm you, one of you, I can figure out how to do that because again, MIPS32 has a very strict representation. Therefore, always is the operation notation and then continue with the destination operand, which is at S0, following by first source operand, followed by the second source operand. Okay, so that is exactly what it's doing here. Okay, so what this really do is one potential application here is, as long as what is the truth table for AND? It is let me just do this way. Truth table will be if it's a one, both is a let's say if both is 1 1, so it will be what? It's difficult to represent. Let me try to think how to represent. Okay, let's represent this way. This way, okay? So if assume T0 can be 0 and 1, right? And the T1 can be 0 and 1. So what is the truth table? Here, 0, 0, the corresponding bit for S0 will be 0. And then if 0, 1, here's a 0, right? That's a truth table. If 1, 0, here will be 0. If 1, 1, will be 1, right? So basically, only both of the source operand 1, the corresponding result will be 1, right? All the others will be 0. So in other words, if you try to mask some of the bits, you can set the corresponding bits of the other source operand as a 0. So for example, if I want to mask the second bit of T1, okay? So what I do is I set the second bit of T2 as 0. By doing that, no matter in that second bit of T1 is 0 or 1, the final result, the second bit, always 0, okay? So here, right? I just give you an example, right? For example, assume, okay, again, and T0 is a 4-bit, T1 is 4-bit, okay? So if you say T0 is, let's say 0, 1, 0, 0, 1, 1, okay? And then if I want to mask the second bits of T0, right? So what I do is I just, I don't care the other ones, and actually I care the other ones, and it's I can set it this way, T1 as this, right? By doing those, the other bit, corresponding bit, will be keep it original because all the other bits for the T1 will be all 1. So that means after do the bit by bit and the corresponding bit, the final, just give S0, you can see the first bit will be still 0, right? Because to do the bit by bit and the between 0 and 1, the result is 0. bit by bit between 1 and 0, the result will be 0. But do the bit by bit 0 and 1, result is 0, and bit by bit between 1 will be 1. And by doing that, you can see the corresponding bit for the second corresponding bit of the S0 is 0, which successfully mask write this 1 but with a 0. So all the other bits are keep the same, right? You can see. The reason is because I assigned the other bits of T1 as 1. Basically, that will enable to keep the original bits of T0. I hope that is clear. Okay, just make another example. I just randomly say, and the T0 is 0, 1, 0, 1. Okay, I just randomly say if T1 is 1, 1, 0, 0. Okay, you're supposed to be able to get the S0 as what? 0, right? 1, 0, 0. Okay, I want you to figure out that by yourself and then try to compare whether this result is the same as yours. Okay, so after that, we try to look at the OR, similar to AND, right? The OR, the only difference is I change this operation code from AND to OR. That's it, right? It still follow the regulation of the R format. This operation, right? First and destination, first, let's say one more time. This operation and then followed by destination operand, and then the first source operand and second source operand. The only difference is logic table is different, right? The truth table is different. If both of them are 0, here is 0, but if one of them are 1, here the result will be 1, right? If both of 1 will be 1. So similar, if I try to implement OR between these two, well, the result will be 1, 1, 1, 1. Right? Because as long as one of the element is 1, the result will be 1. Similarly, if I implement the OR between these two source operand, I can get 1, 1, 0, 1. Because only when both of them 0, the corresponding bit will be 0. Okay? So this thing is also has their, the application. Basically, you want to set some false some bit as 1. You can, and leave other things unchanged. You can smartly set the corresponding bit of T2 in order to achieve this goal. Say one more time. You want to set some of bits of T1 as 1 in falsely. You can achieve that by carefully design the number bit of the T2 in order to achieve this goal. So because we explain in detail about the AND, how we mask the bit, here I hope you can figure out by yourself. If you have questions, please send me email, okay? So now we come into the questions about the NOT, okay? If you recall, we said NOT is different with an AND, or shift. NOT, although we try to implement logic NOT, but the instruction using more, I ask you, right, to think about why. So let's just try to look at here, okay? So for example, I try to, implement NOT on T1, on T0. So if I want you to represent using the assembly language, how you can give me that corresponding assembly language. Let's say I try to implement logic NOT on the source operand T0, and then use the result to update S0. Okay, I want you to use assembler. Just think about it. Don't look at your slide. Just think about how you can achieve this by writing assembly language. So pause here and try to figure out by yourself, and then continue this video to see whether we get similar idea. So similar idea is if I still using NOT, okay? So what I can get, assume still using NOT. What I get is the following. right? So basically, I try to implement not on this only one source operand T0 using a value to update as 0. So what's the problem here? Again, pause here, try to think by yourself. The problem is I want to implement or represent a logic operation such as not by using R format. But here, I only have one source operand. In other words, I do not have another source operand to enable representing this not logic operation by using the R format. I mean, it's one source operand. Is that correct? Say one more time. If I directly use not as the instruction to implement logic not, I basically only have one source operand. It's difficult, because of it, it's difficult to represent this not logic by using a standard R format, which requires two source operands. So this actually is the original motivation why we're using NOR instead of not. Okay, so first I just give you the results and then let's try to figure out why it is correct. So I still want to represent this, the original high-level operation. But here, instead of using not, I using nor. Nor is not or, right? So I can represent as following. Okay, so basically I implement NOR between the source operand T0 and the 0 register. If you recall, what means 0 register? The first register in that 32 general register list, right? And that value always be hardwired to low voltage. In other words, that value will be 0, right? So in that way, that means what? I try to implement not or, and let's try to see. So let me see how to represent this. Let me try to do this way. Okay, so I try to do T0 and then not or and 0, right? Right, that is what I try to implement. Let's see whether mathematically I can get the T0, which is actually the not operations result, okay? Which is the operation result of implementing not. So basically now I try to using the NOR, right? So I think this way. So this way, right? Not or, okay? So and then that means what? That means not T0 and then and not 0, right? And what is continued, right? So basically it's not or is equal to not, and then using and to connect, right? And then that will be what? This part is basically is not T0, right? But the other one is what? I said register 0 always has the value 0 and you implement the not. So basically is 1, right? And that will be what? Something and 1 will be something itself, right? Therefore, I can get it this way. So that is exactly what we try to implement, right? So this is a mathematical we can prove this NOR as 0, T0, 0 is equivalent to this. But the good thing is we introduce one more source operand, which is register 0, which enable us to complete this assembly language by using the standard R format. This is exactly the original motivation why we use NOR to implement the not instead of the not itself. Okay, so let's show here, right? If you want to implement the not on T1, use that to update T0 is equivalent to do NOR T0, T1, and 0. Okay, And here is using one example to show this exactly what we try to do. Okay, so I hope this is clear to you. Now we have another additional logic operation. Is not commonly used or it's not the focus for our class, but it's also good to know when it's an exclusive OR, right? So basically, I try to implement exclusive OR between the register T1 and T2 using that value to update T0. Again, exclusive OR, what is the logic matrix? So the truth table, well, 0, 0, here will be 0, 1, 0, here will be 1, 0, 1, here will be 1, and 1, 1, here will be 0, right? Basically, only when the bits are different, I will have the corresponding result 1, otherwise it will be 0. Okay, this is also shown here, right? If it's, you can see, if it's a 0, 1, here is 1, 0, 1, here is 1, 1, 1, here will be 0, 1, 1, 0, and so on, okay? So I said, right, if you involve some small constant for your one of the source operand, this will be similar to the add immediate. You will use the immediate format instead of the original R format. In other words, you will return that small constant in the immediate field. I hope you still remember how to represent the immediate format. Again, immediate basically using the I format, right? So basically, let me do here. Basically will be 6 segment will be operation code, right? And the RS, RT, and the immediate field. Basically, so right. So therefore, here will be represent code. Sorry. So here will be represent the corresponding index for corresponding instruction. Here will be the first source operand. Here will be your constant, which is second source operand, which is constant, and here will be destination, right? And the assembly language show is as the following, right? So basically, still operation, destination, source, second source, which is constant. Okay, so here actually there's no immediate word. You can see there's an immediate word for and, for or, for exclusive or, but there's no immediate word for not. So why, or nor, why? I want you to pause here to think by yourself. The reason is for nor, because the main purpose using nor is to implement not. And the second, this source operand already fixed, that is register 0. You cannot change to other random constant. Therefore, there's no immediate word for nor. Okay? So I think because today we already used a lot of time to talk about logic operation, so let's stop here, and then next class we will continue with the section 2.7. Again, I'm really sorry for the inconvenience caused my urgent travel. I will try to figure out, manage to go back to the regular physical class as soon as possible. I will, as long as I figure out the date, I will announce in the Brightspace. Within this time, I really appreciate your support, and I will provide all the videos online. And if you, in the Brightspace, if you have any question, feel free to email me your questions. I will try my best to give you an answer as soon as possible. Okay, thank you.